Well, the challenge with carbon fibre isn't so much how strong this material is. The challenge there was really how can we manufacture it efficiently, and with that as well, recycling. He said, guys, I've recycled it 3 times and the material got stronger. Does this technology have legs for commercialization? Would you buy a product like this? And yeah, that really kick-started Lineat. I remember doing research and you get a result and you're like, yes, it worked, you know, but it worked maybe 1 out of 10 times. Commercially, I would say, is it has to work 90% of the time. We'll have machines in the US, we'll have machines in Europe mainland, and machines in Asia, taking chopped carbon fiber sources, aligning them, and they going into a lot of components.
Today's sponsor is Composite Source. Sourcing the right materials and tech for your composites project shouldn't slow you down. They are your ultimate US-based procurement partner, handling everything from raw materials and custom manufacturing to specialized industry staffing. Stop searching and let the experts scale your production. Visit composite-source.com or click the link within the description. Lourens, thanks for guiding us through the workshop or the production facility, however you call it.
Yeah.
Now, let's come back to you. Please walk us through your background and how you basically discovered and then moved forward into composites.
Cool. So my background is in aerospace engineering, which I studied back home in the Netherlands, really because I liked engineering and thought aircraft are cool, let's start that. And in that journey, at some point, start to work with carbon fiber materials to make a carbon fiber wheel. And I remember this very much, just one evening you're studying, probably similar as sort of what you have in Zurich, student team. And I was like, this is amazing. Cut some fabrics, brush some resin on it, cure it, mold it. You got something that's lighter than aluminium, stronger than steel. So I was like, this is pretty epic. By then, a lot of the carbon fiber and composite development was happening in aerospace. So continued that for my master's. Really focusing mainly on the computational mechanics, so the calculations of it. That led me to spend a year at BMW in Munich, looking very much at the crash worthiness. So again, how does carbon fiber composites, how do they break? And that's kind of where I learned, well, the challenge with carbon fiber isn't so much how strong this material is. We can do layup optimizations. We can do classical laminate theory calculations. Got to break a lot of things, which was fun. But the challenge there was really how can we manufacture it efficiently, and with that as well, recycling, which wasn't really in 2012, this was-ish, wasn't really a hot topic yet. So after a year at BMW, decided to move to Bristol to do my PhD. And that's where I came in touch with this technology to align chopped carbon fibers. And I remember this from my degree, that this calculation on critical fiber length, which is a really funny one to do. You have a rod, you look at your area, how much length do you need to get your full strength of your fiber. It's like this has got something. So it was a PhD project to look at 3D printing with aligned fiber filaments. Done that, worked on the lab prototypes that, yeah, probably is in the space we are in now, but about half of it had a small fiber alignment machine. And I remember a moment there with a PhD student who was working there at the time as well, Reece Tapper, and he was doing thermoplastic aligned fiber composites and looking at recycling those. And he had some results. He said, guys, I've recycled it 3 times and the material got stronger. And I'm like, wow, so that's kind of I think the click, like, wow, this technology can really do something. So from there, finished PhD, and there was a bit of funding to build a bigger fiber alignment machine. I just finished my PhD, so it's a natural progression. Built that machine at the National Composite Center. So it's a very natural sort of university research, gets pulled through. I think the program was called the Technology Pull-Through Program there as well, on a slightly bigger scale. And then there was another pot of funding to look at commercialization of university research. Yeah. So again, I think lucky, you know, Bristol, right technology, right timing, and then this opportunity to get involved in a 3-month sprint project. Okay. This is in 2020, COVID time. Yeah. Does this technology have legs for commercialization? Mm-hmm. So 3 months, stopped the research, So I got the iCure program, and just spoke to people on composites industry. So like, do you want recycled carbon fiber? Would you buy a product like this? And yeah, that really kick-started Lineat. The network, the people, the work we did with Wilson came from that program. And then at the end of it, I thought, well, why not? So reached out to people I worked with then. So Lewis, our current COO on the machine side, are you keen to join Lineat? And we need a commercial person. I knew Gary from before and started Lineat Composites. 2020 was a good time for investment. A lot of money wasn't moving. Here's a couple of guys who say, yo, let's make a business out of carbon fiber recycling. Just a fresh spin out, got it started, and that's the machine you saw downstairs that kick-started it. So that's a bit of the journey up till 2020.
Cool. Yeah, so you mentioned a lot of interesting points. I mean, BMW, at that time I was at SGL, we had this joint venture with BMW also on these new processes, also discovering what it means to get a lot of waste and needing to find a solution, because automotive is already pretty much at the forefront of these recycling topics by regulations and by scale. And also speaking about the 3D printing filaments and so on, so many parallels here. But then you spoke about all these steps from being a PhD at university, kind of spinning off to the NCC with the program, getting financial support. So how much is it a process here at Bristol University? Is it a spin-off process? Was it more opportunities at that time? Because at ETH there is a clear process of how to spin off from university up to getting your first fund from VCs. Is that the same here?
It's a good question. I can't really compare to other universities. There are other startups from the University of Bristol, specifically the Bristol Composites Institute. So I think it's a bit of a culture thing, and of just the people, seeing other people who spin out companies, do a similar thing. That kind of gives that idea, right? I think that has a big role. It's probably the same in Zurich. And then the financial support programs that it as well, they help as well. So I think that's definitely kind of the two ingredients you need. One, a clear program to kind of allow people to take a step away from their research. But it's also a culture thing of, can we get the right people who, entrepreneurs, like, let's just, you can create things, you can make things, which, comes down to personality, I think, and seeing other people doing it, which the Bristol region clearly has.
Yeah, and it's also finding the right partners. So obviously you mentioned with COO, and then finding a business person to, as a trio, drive the company on the right path. And actually coming back to growth, because obviously, I mean, you worked on the topic for quite a while, then you find your co-founders. So this is the fundamentals of the company. And how from there you grow also in people. Which kind of people do you need to build up something new?
Yeah, really, another good question. I think on sort of the founders, I once read a nice article by an Italian economist. I forgot his name now, but he always looks for, if you look at development aid, and that was a topic, you need sort of 3 different people to start a business. One on the finance, one more on the engineering, and one more on the sales. So that sort of the delivery, the keeping the checks and the promise. So we definitely got lucky in Lineat, I think, having those people around. As 3 founders. Then growing that, it's so important. You've got no end of tasks at the start, and people can put their hands into a little bit of everything is really key. And I think if I look back at some of the key hires we made, again, some people are still with us, is the ability to take this sort of idea from when you sit at a desk, to then actually bolt something together or come up with a way to devise it and build it. And that's in big companies, it's often, I think, two different departments. We call it, throw it over the wall kind of thing. That's the kind of people that have made a really big difference in Lineat. Of actually, let's actually take that idea and make it happen as a quick proof of concept, and then you can come back like, look, I've got a bit of proof. That's key, and everyone on the startup just being like, everything we do matters. So on the tape quality line or on the tape production line, producing tape, actually, if it doesn't look good, if you think it doesn't look good, okay, stop, this needs to be improved. It's not a job where you can be like, yeah, it's good enough. It's, things going out of the door, that matters. Let's focus on that, and as a company, all agree to that. Those are, I think, two sort of key things. So taking that desk to workshop and always looking at how can we do something better.
So really, doers taking responsibility.
Yeah.
In a certain way.
And what I often say from university spin-outs, or my sort of comparison, my background was very academic before starting Lineat, is I remember doing research and you get a result and you're like, yes, it worked, paper. But it worked maybe 1 out of 10 times you tried it. So 10% success rate. And that's really what the difference is when you try to do something commercially, I would say, is it has to work 90% of your time. Yeah. If you get a phone and you start it and you click 10 times and it only works once, nobody would buy it. Correct. And that effort to get from something that works in concept to make it work again and again, and consistency, that's what really these 5 years have been. And we're still at that last 10% of, we can run it and we can do extended shifts, but can we now also just get that consistency always there, which we're focusing on? And it again comes down to operators, comes down to setups, and we're in that phase now of trying to write everything on standard operating procedures and say, okay, this is the way you do it, every time the same, which we didn't have before. We could try everything, and now it's like, it's a product, this has to get the same. So it's a transition.
Interesting. And when we were downstairs, so you shared that the heart of the technology is the alignment, obviously. But when we look at the entire process chain, so in the machine, let's say, if you call the entire process chain a machine, this is only one bit. So the other bits, they are not, they are necessary to make it happen, but they are not the core of you as developing technology. So how important, coming back to ecosystems, is it to have also strong companies to work with rather than reinvent the wheel for some process steps?
Yeah, when you said that, I was like, interesting, where are you going to go with it? Because one thing that was really, I think, important for Lineat is we had to build all of that equipment. If we remove one bit, we don't have a product we can show. So in a way, yes, our bit is that alignment, but we had to build everything around it to make the product or show the product. And we were talking earlier about on 9T labs. And naturally, when you just start, you do a lot of it yourself. Yes. And we're now realizing actually a lot of these parts, now we've built them, we can show it to someone, can you build this? And they can do a better job at conveying systems or at tunnel dryers than we can. So that's on the supplier side. Another one in the composites industry, key, was the resin. So, composites is, you need your fibers and your resins. And that was tricky early on. Having spoken to a lot of people in the composites industry, there's a lot of sort of know-how in the resin side as well. So finding a company that is willing to provide some resin film, to try this thing, wasn't easy. This is where we built that relationship with SHD Composites, which has been really good. And they've really helped us pull along as well and give advice from supply of the material, but also wider working with them on sort of understanding the market and where it fits, which is still something we go on today. So that's been really crucial, I think, in those early days of development. You're not on your own. You got suppliers, but also your key ingredients on the composite side.
Yeah. So it's really from, okay, you need to make it happen, to being able to spec what is not core, build it more solid, have a clear blueprint factory, let's say. That's probably the goal, and then you can move to the next steps, being selling the technology, licensing it.
And once you've proven it, and it is simpler. Yeah, the best solutions are always the simplest, right? The best part is no part, kind of quotes. We're definitely looking at that, and that's what I remember. And I love doing computational analysis and doing all of the calculations on the process and putting control valves and measurements everywhere. But a lot of it is like, do we actually need this? Can we design the process such that we can remove it? And that's kind of where the first machine you see, we'd said, well, let's put a flow meter in, and let's actually confirm that. Let's put a control there. But we're actually seeing, well, if we can start removing some of those bits. Yeah. So I think we're sort of in the transition now. We have the next upgrade still with a lot of instrumentation. But after that is already on that simplification route, because you know your process better.
So it's really asking, is it necessary? Can we do it differently? And then, as you say, decomplexify to make it more robust. Because at the end, we often speak about non-consistency of waste, and for you as a material producer, at least provider of the fiber part of the final material, you want consistency.
Yeah.
So that's...
and this is, we discussed that earlier downstairs. It's like the focus on industrial waste at the moment is the right choice for Lineat, but our sort of vision is make more out of carbon fiber, is get carbon fiber recycling rates, at least let's double them. So at some point it means looking at the wider waste out there from broken components. And that's if we create a product now, and the process, the consistency, that's our first product. If we then change to a mixed fiber source from end of life, so maybe we can't guarantee exactly what fiber type, but we can guarantee a mix, and that mix might be way cheaper. I think we have a very attractive product where we can, at least through process control and batch control, guarantee minimal properties. Yes, but you can get very competitive in terms of pricing. But that needs the first step in the carbon fiber recycling process also to grow. The end of life reclamation, the pyrolysis, solvolysis, superheated steam, those ones. So I do think that will change with scale. Very large facilities exist already to do that fiber resin separation. So we need to be ready as well to handle those fibers on these machines, and then together we can get a very nice product. For sure.
And now you're speaking about the feedstock, you being capable of treating it and making a product. But now we need people who use it and now know how to use it. So now we're coming to customers. Tomorrow we are visiting a wheel manufacturer. And here, maybe you can tell us a bit more about why did they select the product, and why is it also important sometimes to separate sustainability from real functions at engineering level?
So where did it come about? We met with this wheel manufacturer at the ICS, International Composite Summit in the UK. Very early days for us. That's just when we started producing some material. And just, I think it's a scale thing as well, or maybe again a culture, smaller company, something new. Let's try this. So it was literally like, let's send a sample out. And because it's smaller scale, you don't look at it with a head of, I need to make 5,000 parts and I need to do it and with a slightly higher margin, or I need to reduce my cost, which I imagine is the main way of thinking in a lot of industries, which is the right call for scaling. But we're not there yet. This was more, let's do something different. Let's see what we get. So that's really where that started. Implement it, make that end product. Oh, it's molded quite nicely. It had quite nice vibration properties. Let's look more into that. So once you find that, you can start to focus on that little benefit. And we share that with all of our customers pretty much, and everyone we speak to. Look, this is the product. Yes, it's recycled. This is where it can excel. And if you're going to replace 100% of UD virgin carbon fiber with our recycled version, you're not going to get the optimal performance. But which composite is 100% UD? So that's really the composite side, the chefs. It's like kind of thinking, I think something is like that might work. And we're doing that with other customers now as well, as like using it in different ways.
Cool. So you're teasing already other applications, other markets. And I mean, that's a good way to close the conversation. Eventually, where do you see the company in 5 years from now in terms of maturity and also developing the business beyond the facility here?
Well, we'd still be here developing better alignment technologies, but we'll have machines in the US, we'll have machines in Europe mainland, and machines in Asia, taking chopped carbon fiber sources, aligning them, and they going into a lot of components. So it's a bit like we're growing this brand as a Gore-Tex of the composite industry. This is, the recycled portion, and we're finding out more and more as an industry and with our customers how to best use it. Ultimately, that's when we look at a broken component, we're not like bin. Actually, we're like, we can use that.
Okay, so seeing as a resource rather than pure waste.
Exactly.
Cool. I mean, very interesting insights, Lourens. Thanks again for the tour, for the insights. As a last word, eventually, how can people reach out to you?
LinkedIn is probably best. Go on our website. There's a form or email there as well. So if you want to find out more, or even better, if you have manufacturing facilities and want to put some aligned recycled carbon fiber strips in there, see what happens, please do reach out.
Cool. Thank you so much, Lourens. I appreciate your time and see you soon.
Cool.
Cheers.
Yep, thank you.
Good.